Yeah, so good afternoon, everyone. So we will be talking about next important concept of our session, that is certainty factor theory, which is an alternative approach for your Bayesian reasoning. So in previous session, we have seen about Bayesian belief networks, which is an important concept of probability, which is used for as application for your artificial intelligence whenever there is a some uncertainty. But even Bayesian belief network has some limitations. It can give reasoning only till some extent. Still, there will be some ambiguity or some uncertainty in the result. Then that's the reason we need to move for the next concept, that is certainty factor theory. Okay, so as part of this session, we will be addressing the main concepts of certainty factor theory. What is its significance? When should we use certainty factor theory? And also how this can be applied to an intelligent machine, and that's why we call it as application for your artificial intelligence. Okay, yeah. So the first line here we can see, as we all know that when analyzing a situation and drawing certain results about it in the real world, we cannot be 100% sure about our conclusion. So the first line here talks about it can be a human being, or it can be an expert system, or it can be an intelligent machine. Anything which cannot 100% say some result is being true or false, there will be some deviations in the result, because there can be a number of chances that there's, due to uncertainty, we may get some false assumptions. That's the reason we cannot 100% give our answer accurately every time. So it might be a human being or it might be an intelligent machine. But coming to human beings, whenever there is some uncertainty, so we have some because we have brains, we will be analyzing our the situation. According to situation, by looking into result, we will be coming to some conclusion based on the observations that the result obtained is true or false. So because of the thinking capacity what a human being have, he will be having n number of opportunities or thinking skills to decide whether the given statement is true or false, according to how much certain we are about our observations. But think the same situation with respect to an intelligent machine, which is having knowledge based on the domain expert knowledge, whatever is given. But that's the reason machines do not have this analyzing power. So there needs to be some method to quantize this or uncertainty in any decision made. So whenever a decision is made by an intelligent machine, that need to be quantized, that need to be once more like can we directly take the decision, or is there any uncertainty in the decision, that should be seen. So to implement this, to solve this problem, we are going for the next concept, that is the certainty factor, which was introduced for systems which work on artificial intelligence. So Bayesian belief networks, the Bayes theorem, the concepts of probability can be used in n number of machine learning approaches. But certainty factor theory, whatever we are going to learn now, is exclusively used for your artificial intelligence. So certainty factor theory is a popular alternative to your Bayesian reasoning. Okay, that's the reason we are learning it immediately after your Bayesian belief network. Okay, yeah. So coming to the definition, so everybody should make a note on this definition. So certainty factor is a numeric value which tells us about how likely an event or a statement is supposed to be true. So basically, this is a common definition for probability also. So even probability also, we will be doing the same thing, like how likely an event or what is the chance of getting some event as success or failure. That's what we have will discuss in probability. But here it is somewhat similar to what we define in probability, but the difference in it is that an agent, after finding the probability of any event to occur, cannot decide what to do. So basically an agent will find the probabilities, and according to the values what it is obtaining, it will give the result. But here the situation is an agent should also decide what need to be done. That's the reason we are going to certainty factor theory. But how an agent can do this? What are the things necessary for an agent if it want to make some decision? So it needs some probability calculation value, and also it need to ensure that it has some prior knowledge in that area because of the from the domain expert. That's what we have learned in the expert system. So based on the probability and other knowledge that the agent has, the certainty factor is decided through which the agent can decide whether to declare the statement true or false. So it is clearly saying that based on the probability and other knowledge here is the knowledge given by the various domain experts to that agent through an expert system. So based on all these things, a certainty factor theory is used to provide some valid reasoning whether the given statement is true or false. Okay. Yeah. So how does a certainty factor theory work? What are the important things what we need to understand with respect to certainty factor theory? So here, basically, as it works based on the given some values, the range of certainty factor theory for any decision making lies between -1 to +1, where the negative value, that is -1, indicates that the given statement cannot be true or it is a false in any situation, and positive one, that is +1, defines that the statement can never be false, that is it's 100% true. Okay, so according to the given condition, -1 indicates that it is a false statement, +1 it indicates that it is 100% true statement. That's what an agent will assume according to the certainty factor theory. Okay. Yeah, the value of certainty factor after analyzing any situation will either be a positive value or negative value between the range of -1 to +1. It's not exactly -1 or +1 always. The value ranges from -1 to +1, and sometimes value also can be 0. So whenever the value of 0, the agent, it suggests that agent has no information about an event or any suggestion. So we need to keep this in our mind. Whenever certainty factor theory value is 0, it indicates that the agent has no information about that event. Other than that, if it is 0.1 or any value between -1 to +1, it indicates that it has some information about that event and it will give that result. Okay, so as part of this concept, we need to remember that the value of certainty factor theory ranges from -1 to +1, and whenever it is 0, it means that the agent doesn't have any information about particular event or any particular situation. Okay. Yeah. So a minimum certainty factor is decided for every case through which the agent decides whether the statement is true or false. So yeah, here comes an important observation. So because the value ranges from -1 to +1, so what if I get a value of 0.5? So what should I do with this value? So according to the value what you are obtaining, that value need to be compared with a minimum certainty factor value, which is called as a threshold value. So the result whatever you are obtaining, that value should be compared to the threshold value. The threshold value will be decided, and according to that threshold value, the conditions will be checked and it will be decided whether to take forward or not. For example, yeah, if the minimum certainty factor theory value is 0.4, that is the threshold value what we are assumption here. Then if the value of certainty factor is less than this value, then the agent claims that particular statement is false, because the value is less than 0.4, the result whatever is obtained is less than 0.4. The agent assumes that this condition is false because of the threshold value whatever is given in the algorithm or in the given concept. Okay. Yeah, so here you can see some important uncertainty terms and the interpretation of some values which are indicated, which are fed to an intelligent machine. Suppose if the result of the value is -1, as I said, it is definitely not. That is as I said, it is 100% false. If it is +5, it is definitely true. That is 100% true. And any value between -1 and +1 has some indications. That is, if it is -0.8, almost certainly not, because -1 indicates certain, definitely not, and -0.8 indicates certainly not, -0.6 indicates probably not, -0.4 indicates maybe not, and similarly -0 to -0.2 to +0.2, it is unknown value. So that is the range where it cannot decide exactly what should be done. As I said, if it is 0, it doesn't have any proper information. That's the reason -0.2 to +0.2 is considered as unknown values. The same vice versa here, +4 indicates maybe, probably, and almost certain. So everybody need to remember these values as part of your examination point of view, this value should be written in examinations. Okay. So, so here comes one important observation about certainty factors. How we need to decide for as we're talking about artificial intelligence, we basically talk about Lisp programming language and or also Prolog programming language. So, in expert systems with certainty factors, the knowledge base consists of set of rules that have the following syntax. So, because we are talking about some intelligent machine, because we are talking about some important algorithms, whatever we are talking about, some different approaches, it can be Bayesian belief network or any approach, it has some set of rules and it need to follow some syntax. So here certainty factors, syntax goes here like if evidence then hypothesis. So because evidence means in any situation, whether the statement should be yes or no, it should have some evidence, then only we can come to some hypothesis, that means some conclusions. That is the key term we need to provide in algorithm whenever we are developing any AI machine or intelligent machine, where CF represents belief in hypothesis H given the evidence E has occurred. So E indicates evidence, H indicates hypothesis. Okay, CF indicates certainty factor. Yeah. So, as I said, we need to learn about the significance of certainty factor in designing rule-based system. So, what actually is a rule-based system? So, previously we have said that if there is then some if evidence, then only hypothesis. So, we need to follow some set of rules which forms a rule-based system, and certainty factor theory comes under a rule-based system. Okay, yeah. So coming to the significance of certainty factor, it is a simple approach and popular alternative to Bayesian network, or we call it as Bayesian belief network. Certainty factor is used in cases where the probabilities are not properly known, or when it is difficult to find the probabilities, or whenever the situation is very expensive to obtain. So at the situations, we need to come across these certainty factors. So if you're having all the probability values well and good, we may go with the Bayesian belief network values. But in cases where you're not having very good probability values, whenever they are not known or whenever they are difficult to identify, then we come across this certainty factor theory. So better explanation can be given by using your rule-based expert systems. That's why it comes under rule-based systems. Okay, yeah. So mathematically talking about this certainty factor, yeah, sorry, certainty factor theory is based on two important observations or two important functions, that is measure of belief in hypothesis and evidence, that and also measure of disbelief, as we call it as yes or no. It is like belief and disbelief here. So here MB indicates measure of belief, MD indicates measure of disbelief, and H indicates hypothesis, E indicates evidence. Okay, so if as part of your concept of certainty theory, the questions can be asked in a number of ways. So mathematically, if the question is asked, you need to use these expressions or the formulas given here. So if the probability of hypothesis is equal to 1, then we use this maximum, that is belief formulae. Or if the probability of hypothesis is 0, then we go for disbelief, then we use this equation. So everybody should please take a note of this equation, because examination point of view, you need to compute these equations, or you need to write this equation in examination. So here P of H is the hypothesis. As I said, P of H by E is nothing but the conditional probability that the H is true when E is true, or H is false when E is true. That's what we have seen in the Bayes theorem, right? The same manner, P of H of E is the conditional probability. That's what we compute here. So we will be calculating the measure of belief or measure of disbelief, and according to that, we will be saying the hypothesis. So P of H is the prior probability of hypothesis H being true. P of H by E is the, or H with respect to E is the probability that hypothesis H is true given evidence E. That's what, as I said, it's the conditional probability according to the given two mutual exclusively event. Okay, yeah. So so we are computing these two values, like measure of belief and measure of disbelief. Now we will try to compute the certainty factor theory based on the two values obtained. Okay, so the value of measure of belief h comma e and measure of disbelief h comma e range between 0 and 1. The value can be 0.5 or 0.6, anything between 0 and 1. The strength of belief or disbelief in hypothesis h depends on the kind of evidence E observed. So basically, the hypothesis can be derived from the given evidence. That's why evidence is an important factor with respect to the certainty factor theory. Some facts may increase the strength of belief, some increase the strength of disbelief. So evidence is the important factor with respect to this certainty factor. Okay, the total strength of a belief. Suppose we have got some misbelief and some disbelief, or we call it as measure of belief or measure of disbelief. So based on that, we need to compute the certainty factor theory using this equation, that is measure of belief in h comma e minus measure of disbelief in h comma e divided by 1 minus 1 minus measure of belief h comma e into measure of disbelief in h comma e. This is the computation or mathematical representation of certainty factor, and everybody need to remember this as part of your examination. Okay, yeah. The certainty factor theory provides a practical alternative to Bayesian reasoning. Okay, that's how this can certainty factor theory can be practically used as a belief with respect to your alternative for your Bayesian reasoning. Okay, yeah. So there is some small assumption that the certainty theory is not mathematically pure, but does mimic the thinking process of a human expert. That is, according to the Bayesian belief network, which is mathematically pure, certainty theory might not be mathematically pure, but it provides an illusion that it can add some intelligence to an intelligent machine or an expert system like a human expert. That is the belief according to your certainty factor. Yeah. So now let's talk about one important application which has already been discussed. So when I explained about unit in the starting of unit, I said applications of some expert systems. Yeah, going to the initial slides. Yeah, 1 second. Okay. So here in the beginning of chapter 3, we have seen some examples of an expert system. Here we have listed some expert system like Dendral, Mycin, PEXDs, and Cadet. These are some of the expert systems which are being widely developed in many countries, and they are widely used also. So Mycin is one example of an expert system which we will be discussing now, which comes under the certainty factor theory. Okay, yeah. Just give me a minute. Sorry. Yeah. So Mycin is one important application or a real-time expert system which is being designed in Stanford University in the year 1970s only. That was an earlier invention or early design of an expert system which is most widely used in current days also. Mycin is a well-known rule-based detection system. Its expertise lies in the domain of bacterial infections with respect to some blood. That is, whenever we have some infections in a blood, we actually approach an physician or a doctor, and they will recommend you how much percentage of infection has occurred. And Mycin also works in the same area. It has all the knowledge with respect to the blood samples, whatever you are going to give as a input. It will recommend whether what a physician need to do according to the blood samples whatever being collected and the reports whatever are being given. So its job is to diagnose and recommend treatment for certain blood infections. It attempts to solve its goal of recommending a therapy for a particular patient by finding the cause of patient's illness. So whenever reports are being given to an expert system, the values are fed into the expert system. According to the domain expert knowledge, whatever it is having, it will try to give some recommendation, recommending a therapy or solution for a particular patient by first finding out the causes. The causes here are the important observations, whatever the patient is given to the expert system. So the expert system will take some inputs from the user, and according to the inputs, whatever a patient is giving, it will try to recommend some therapy. That is the intelligent machine here. Okay, yeah. So because it comes under application of artificial intelligence, we need to develop any application of AI with respect to your Lisp programming. So Mycin was written in Lisp programming in the early 1970s only. Okay, yeah. So Mycin is mainly a goal-oriented or goal-directed system using the backward chaining reasoning approach. So we are not concerned about this backward chaining and forward chaining, which is not part of our syllabus, but we need to have an understanding about this thing, like what is a backward chaining process. That is, it will try to go into the various sections of domain experts knowledge, and it will try to compare the previous results, and accordingly it will try to give the accordingly a good recommendation. Okay, yeah. So Mycin helps the physician to prescribe disease specific drugs. So according to the blood samples, whether it has some disease or whether it is a normal observation, whatever is the recommendation of the expert system, it will try to provide some specific drugs to the physician. That's how Mycin is a real-time application which everybody need to understand with respect to some certainty factor theory here. Okay, it's an example for an expert system which is being developed in 1970s at a Stanford University. Okay, yeah. So now let's try to compare and clearly understand differences between Bayesian reasoning and certainty factor theory. Okay, so when I talk about Bayesian reasoning, it's nothing but your probability theory. So probability theory is the oldest and best established technique to deal with inexact knowledge and random data. So whenever you are having some random variables or some randomness in your data, we actually go for probability and try to find the chances of whether an event is occurring as true or false. So it works well in such areas, as I said in previously, with respect to some forecasting, some burglary attempt, and planning, where statistical data is usually available and accurate probability statements can be made. If the data is available and if you can make some accurate decisions, then we actually use your probability theory. So however, in many areas of possible applications of expert system, reliable statistical information is not available. The exact values are not available all the time, so we cannot assume the conditional independence of evidence. So as a result, many researchers have found Bayesian method unsuitable for this work. Okay, so whenever you are not having a proper statistical data, at that time Bayesian belief network or Bayesian methods are not well suitable. That's the reason we are going for certainty factor theory. This dissatisfaction motivated the development of certainty factor theory. So whenever there's a question arised, difference between this Bayesian and certainty factor theory, you need to explain this point very well. Okay, so because of the dissatisfaction of the Bayesian belief network with respect to some unavailability of some data, we actually move to some certainty factor theory. Okay, yes. Although certainty factor approach lacks the mathematical correctness, as I said in the previous explanation, there is the mathematically certainty factor theory is not pure, but it creates some mimic in the understanding of an intelligent system with respect to a human expert. Okay, so correctness of probability theory, it outperforms subjective Bayesian reasoning in such areas such as diagnostics, what we have seen previously in the Mycin application. So whenever in the area of diagnostics, uh, certainty factor theory establishes good relationship between compared to your Bayesian reasoning. Okay, yeah. So certainty factors are used in cases where the probabilities are not properly known or which are difficult or expensive to obtain, which we already discussed. The evidential reasoning mechanism can manage incrementally acquired evidence, the conjunction and disjunction of hypotheses, as well as evidences with different degrees of belief. So, as previously said, if you want to draw some hypotheses from the given evidences, so you need to look into n number of factors, which is the important knowledge an intelligent machine should have. Okay, certainty factor approaches are also they also provide better explanations than the probability theory because of the control flow through a rule-based expert system. It has some rules. According to the rules, it will draw some conclusions. That's the reason certainty factor theories provides better explanations or better reasoning compared to your probability theory. Okay, so the Bayes method is likely to be the most appropriate if reliable statistical data exists. As already discussed, if you are having statistical data, the Bayesian model is well suitable. And if you are not having some sort of statistical data, so expert system or intelligent machine might not have clear understanding, then we actually go to your certainty theory. The knowledge engineer is able to lead, and expert is available for serious decision analytical conversations whenever you are having some statistical data. So, in the absence of any of the specified conditions, Bayesian approach might be too arbitrary and even biased to produce meaningful results. So, it fails to provide some meaningful results. That's the reason certainty factor theory has much good applications with respect to intelligent machines than your Bayesian belief network. Okay, yeah. So. So the next concept, what we'll discuss is about Dempster Shafer theory, which is very important concept with respect to your uncertainties in artificial intelligence. Okay, so talking about the naming convention, the name is given by two important people who have contributed for this concept. That is Arthur P. Dempster in the year 1967. He has initially started this process, the concept, and his student Glenn Shafer in the year 1976 has contributed. And also, these two people's name are combined into the concept name called as Dempster Shafer theory. Okay, so this concept is one important concept, which is an alternative to your Bayesian theory, which need to be learned whenever you're talking about uncertainty in your data or uncertainty in your given concept. Okay, so this theory is being released because of the following reasons. So reasons are very important. So Bayesian theory is only concerned about single evidences. That's the reason whenever you are having some, you need some multiple evidences. So Bayesian theory is not giving appropriate results. That's the reason we need to learn about certainty factor theory and also about your Dempster Shafer theory. Okay, so and also one more reason, Bayesian probability cannot describe ignorance. So why something has ignored cannot be explained by your Bayesian probability, which can be done using your Dempster Shafer theory. That means it makes the concept completely meaningful. That is, it can give multiple evidences. It can also describe why something is being ignored. What are the reasons for the ignorance? Yeah. So Dempster Shafer theory is an evidence theory. It combines all possible outcomes of the given problem. So according to the given situation or the given problem, it will try to combine all the situations. It will try to collect all the evidences, and it will try to give some appropriate reasoning. That's why it is termed as an evidence theory. Hence, it is used to solve problems where there may be chance that a different evidence will lead to some different result. That is, multiple evidences can be considered and it can lead to any result. Okay, that's how Dempster Shafer theory is much more reliable than your Bayesian theory. Okay, so so because we're talking about some uncertainty in your data, the uncertainty in this model is given by three steps. That is, consider all possible outcomes. So it will not only concentrate on one outcome, it will try to concentrate on all possible outcomes. Belief will lead to belief. Here there are two important observations or two important concepts we need to learn. One is belief, other one is Plausibility. Belief will lead to believe in some possibility by bringing out some evidence, and plausibility will make evidence compatibility with possible outcomes. Let's talk about these two things, that is belief and possibility here. So, Schaffer's framework allows for belief about propositions to be represented as intervals bounded by any two values, that is either -1 to +1 or any some range. That is, belief is termed as a support with respect to understanding. Belief should always be less than or equal to your plausibility. Okay, so talking about what actually is this belief, in an hypothesis is constituted by sum of the masses of all the sets enclosed by it. Suppose if I say I am having four conditions, so belief means sum of all these possible conditions. That is, so if I say I am having four events A, B, C, D. Then it will be having 2 power 4 options, which we'll be seeing in the next slide about what actually is this belief mathematically and what is plausibility. Okay, so it is the amount of belief that directly supports a given hypothesis, at least in part, forming a lower bound. So, whenever talking about this belief and plausibility, belief indicates your lower bound and plausibility indicates your upper bound. Okay, so plausibility is 1 minus the sum of masses of all sets whose interaction or intersection with the hypothesis is empty. That is 1 minus intersection of all the components what you are having. As I said, it is an upper bound on the possibility that the hypothesis could possibly happen up to that value, because there is only so much evidence that contradicts that hypothesis. Okay, yeah, so just give me 1 minute. Yeah, so as I said, when I'm talking about the Dempster Shafer theory, you need to learn about this belief and plausibility. Plausibility is 1 minus sum of the masses of all the sets whose intersection with the hypothesis is empty. Okay, we will try to learn this with an small example in the next slide. Okay, so here we are having some small condition, a small example is being taken to understand the concept of your Dempster Shafer theory. Let us consider a room where four persons are presented, A, B, C, D. Let's say we are having four members in a room, and suddenly lights are out, and when the lights come back, B has been murdered, or B is in a dead situation due to stabbing in his back with the help of a knife. So we are having four persons, and among them B is dead. No one came into the room and no one has left the room because room is locked, and B has not committed suicide because there is no chance of being suicide there. Then what? Then we have to find out who is the murderer. So this is a real time or small example we need to understand, and what are the possibilities that the solutions can be obtained. So coming to the concept, according to Dempster Shafer theory, we need to consider these four people A, B, C, D, and we need to find out all the following, all the possibilities, because we are having multiple attributes here. We are having multiple evidences or hypotheses also. So the possibilities are listed here, that either A or C or D, any of them has killed B, or it can be combination of two people, that is AC, CD or AC have killed them, or else all the three people might have planned to backstab B, that is ACD in combination would have killed B, or else the possibility that none of them might be killed, B might get some heart attack or whatever it is, any disorders in the body that may lead to some death of B. So what are the possibilities we need to compute, and finally get to some conclusion. We need to say who is the murderer by providing some proper evidence. For that, we actually tend to use Dempster Shafer theory. Okay, so one second. This will be the possible evidences by which we can find the murderer by measure of plausibility. So we need to find out the plausibility here. So using the above example, we can say the set of possible conclusion, we are indicating it using your P, that is conclusions can be P1, P2, so on till Pn, where P is set of possible conclusion and cannot be exhaustive, which means at least it cannot be zero or it cannot be at least one of them should be true. So P of I must be mutually exclusive. That is, at least one conclusion need to be drawn from the given possibilities. For that, we will talk about one important probability condition, that is power set. So everybody might remember about what is a power set. So power set is according to the number of elements given in a set, we will be having 2 power n outcomes. That is 2 power n possibilities. So if I say here I am having three possibilities, that is a comma b comma c, then I will be having 2 power 3 possibilities. So in the given observation, from the 4 elements, we are having 3 possibilities, that is A, B, and C. Either A might have killed B, C, or AC, AB, BC, or ABC, and it can be also null set. So here 0 indicates your null set. So we are having 2 power 3, that is 8 possible things. Okay, yeah. So, talking about mathematically about, as I said previously, what is belief and what is K. So, belief in some mass function K, we actually interpret it using your K or B. So, K is the chance or B is the belief. It means there is evidence for K or B which cannot be divided among more specific beliefs for K and B. So if I say K is equal to set of possibilities A comma B comma C, so what is the belief in K? That is, belief in K is equal to M of A plus M of B plus M of C. That is all the possible things we need to consider except null set. So next, plausibility, it is a sum of masses of sets that intersects with the K. That is, as I said, 1 minus all these things indicates your plausibility of K. Okay, yeah. So what are the characteristics of Dempster Shafer theory? So it will ignore parts such that probability of all events aggregate to 1. It will be not taking this into the 1. So ignorance is reduced in this theory by adding one more and more evidences. So because we are not ignoring anything, we need to show why something is also ignored. Ignorance is reduced in this theory by adding more and more evidences. So it's not that only one evidence is considered. We will be having multiple evidences. That's the reason we are not trying to ignore anything. So which basically happens in probability. So in probability, the ignorance is caused in Bayesian theorem. That's why we came to Dempster Shafer theory. And here ignorance is not allowed. That's why it will be having multiple evidences. So combination rule is used to combine various type of possibilities. So all the possibilities will be considered, and it will try to combine them and give you some evidences or results. That's why it is much more reliable than your existing approaches. So what are the advantages and what are the disadvantages? So advantages are, we add more information, uncertainty intervals reduces. So because we are having multiple evidences or multiple possible outcomes, there will be very less chance of ignorance. Dempster Shafer theory has much lower level of ignorance, and it can be applied using your diagnosis hierarchies. Uh, it can be applied for your diagnosis. So person dealing with such problems is free to think about evidences. So what are the possibilities of disadvantages? So in this, computation effort is high as we have to deal with 2 power n of sets. Okay, so that's it about the concept of your certainty factor theory and also Dempster Shafer theory. Okay.